Got a question? Here's the way. Ask the expert here today. Learning starts with today's show. Let's hear what the tech experts know.
Welcome back to Ask the Expert. Today we're going to get technical and explore the results that come from environmental sampling and testing. We will learn processes and methods that environmental scientists take to find contaminants in our soil, water, and air, and how testing is critical to being informed about your neighborhood and environment. If you look at an environmental report, you will see a wall of numbers, abbreviations, and technical terms, which, for most everyday people, may not hold much meaning in our daily lives. This is because these reports are written by scientists for other scientists. However, once you figure out what to look for, you can more easily tease out the story about a neighborhood or site from all this data. Before any conclusions can be made, one must collect a sample from the area of interest. For soil, crews of multiple people go out to the site and dig at specific depths and locations, often following a grid pattern across the property. Following a structured pattern ensures samples represent the site equally and completely. For groundwater, crews install monitoring wells and draw water samples from specific depths below the surface. For air, especially when checking for vapor intrusion, samples might be pulled from the gas stemming from the soil beneath a building. If indoors, the air is drawn in and collected using specialized equipment. Every sample is handled under strict protocols that follow agreed-upon standards by scientists from around the world. The samples are sealed, labeled, and tracked from the moment it's collected until it reaches a laboratory. This careful handing off of the samples matters because it protects the integrity of the sample and makes sure the results can be trusted. Once the samples reach the lab, technicians test them for common contaminants, usually based on what's known or suspected about a site's history. A former dry cleaner, for example, might be tested for solvents. A former gas station might be tested for petroleum compounds. A site with older buildings might be tested for lead or asbestos. Labs use specialized equipment to detect these substances, often at extremely small concentrations. The results come back as a list of contaminants and how much of each one was found, which brings us to the terminology. Let's go through terminology that you're most likely to see in a report. Parts per million, often written as ppm, is a way of measuring concentration, and it tells you how much of a substance is present relative to everything else in the sample. 1 part per million is roughly equivalent to 1 drop of a substance in a large tanker of water. It sounds tiny, and it often is, but for some contaminants, even small concentrations can matter. Exposure limits are the concentration levels that regulatory agencies have determined are safe for people to be around based on how someone might realistically come into contact with a substance. Think drinking water, breathing air, or touching soil. DTSC and other agencies set these limits using established scientific and health research, and they typically build in a wide margin of safety. Risk levels describe the likelihood that a specific exposure could lead to a health effect over time. In California, cancer risk levels are often expressed as something like 1 in a million, meaning that out of 1 million people exposed at that level over a lifetime, no more than 1 additional cancer case would be expected. That standard is intentionally conservative, meaning it's designed to be protective rather than to represent a likely outcome. Detection limits refer to the smallest amount of a substance a lab's equipment can reliably identify. If a report says a contaminant was not detected, that means it wasn't found at or above the lab's detection limit. It doesn't necessarily mean the substance is completely absent, only that if it's there, it's below the threshold the equipment can measure. It is important to understand the difference between the presence of a contamination and actual risk to your health. Many substances exist naturally in our environment, and modern lab equipment is sensitive enough to detect chemicals at levels far below anything that would cause harm. A report might show a contaminant is present, but if it's well below the established exposure limit, that finding does not necessarily indicate a health concern. What actually determines risk is the combination of how much of a contaminant is present, how someone could realistically be exposed to it, as well as how long that exposure might last. That's why DTSC's risk assessors don't just look at raw numbers. They look at the full exposure pathway before drawing conclusions about whether a site poses a real risk to human health. Sometimes a site gets tested more than once. sometimes over months or years, and there's a good reason for that. A single sample only tells you about conditions at one place and one moment in time. Environmental conditions can change. Groundwater moves, contaminant levels can shift with rainfall, seasons, or nearby construction. Repeated testing helps confirm whether initial results were accurate and tracks whether contamination is spreading. After the cleanup work is complete, multiple tests verify that the site remains safe over the long term. This is also why you'll sometimes see the word monitoring attached to a site long after cleanup has technically finished. Ongoing testing is part of how agencies like DTSC make sure a solution continues working. Understanding an environmental health report doesn't require specialized training or fancy degrees, just a little familiarity with terms and concepts involved. Knowing the difference between a detection limit and an exposure limit, or understanding that finding a contaminant isn't automatically a health risk, can help you stay informed when a site near you is being investigated. Environmental awareness is not just for scientists or lawyers, it's for all of us. Understanding what contamination is, where it comes from, and how it moves is the foundation for being an informed participant in decisions that affect your health, your family, and your neighborhood. DTSC's mission, protecting California's people from harmful, toxic substances, is a mission that depends on engaged communities. Their EnviroStore database is a powerful tool you can use right now to look up contaminated sites near your home, your child's school, or anywhere in Sacramento. Visit chastengold.org to learn more. Thank you for watching, and always make sure to ask an expert.
Got a question? Here's the way. Ask the expert here today. Learning starts with today's show. Let's hear what the tech experts know.